So students, let's see this exponential functions limit. Now in this case, we'll consider this limit as two separate limits. Let's see the first one. L1 is equal to limit x tends to 0 plus sine x raised to 1 upon x. In exponential form, you can rewrite this as limit x tends to 0 plus e raised to 1 upon x log of sine x. Now, if you apply the limit, you should know one thing. As limit x tends to 0 plus 1 upon x will tend to plus infinity, and limit x tends to 0 plus log of sine x. See over here, sine x tends to 0 and therefore log of sine x tends to minus infinity. So this will become e raised to plus infinity into, and the other will become minus infinity. Plus infinity into minus infinity is e raised to minus infinity. That is equal to 1 upon e raised to infinity. You can consider anything raised to infinity as infinity, and therefore it is equal to 1 by infinity is 0. Now let's see the other limit, L2, that is equal to limit x tends to 0 plus 1 upon x raised to sine x. Again, converting in exponential form, you can rewrite this as limit x tends to 0 plus limit x tends to 0 plus e raised to sine x into log of 1 upon x. We can rewrite this as limit x tends to 0 plus e raised to minus log x. Sin x can be written as upon cosec x. Apply L'Hospital's rule. Limit x tends to 0 plus e raised to derivative of log x is 1 upon x, and that of cosec x is minus cosec x dot cot x. If you rearrange, limit x tends to 0 plus e raised to minus and minus gets cancelled. 1 upon cosec x is sin x and upon x into 1 upon cot x can be written as tan x. Applying the limit, sin x upon x is 1, tan limit of tan x is as x tends to 0 is 0. That means it is e raised to 0 and e raised to 0 is equal to 1. Therefore, our actual limit x tends to 0 sin x raised to 1 upon x plus limit x tends to 0 1 upon x raised to sin x is equal to 0 plus 1. So the final answer is 1 in this case. So correct option for your question is option C.